Good morning, class. Once again, I'm Miss Rosalie F. Fariulan, your subject teacher for the subject Mathematics. So, for the fifth week of our class, our topic will be about linear equation of two variables. Here are our objectives for this week. We have describe and illustrate the rectangular coordinate system and its uses, describe and plot positions on the coordinate plane using the coordinate axis, define relation and function, illustrate a relation and a function, determine if a given relation is a function using ordered pairs, graphs, and equation, differentiate between dependent and independent variables, describe the domain and range of a function, define linear function, describe a linear function using its points, equation, and graph, and identify the domain and range of a linear function. Here is a simple map of the above lesson that you will going to cover. We have our topic or the main topic, which is the linear equation in two variables. Its subtopic are rectangular coordinate system, equation of a line, and its application. So under the rectangular coordinate system, we have 6 topics, which are abscissa, ordinate, quadrants, axis, coordinate, and origin. Here in the equation of a line, we have 2, the slope and its forms. For the slope, we have positive, negative, undefined, and 0. For our forms, we have general, standard, slope intercept, point slope, 2-point, and intercept form. So let's begin with our discussion. Let R be the set of real numbers. The notation R squared is the set of ordered pairs x and y, where x and y is an element of R. That is, R squared is equal to R times R is equal to x and quantity of x and y, absolute value of x, which is an element of R, and y, which is also an element of R. R squared is also called the xy plane or Cartesian plane in honor of the French mathematician René Descartes, who was born in 1596 and died on 1650, who is known as the father of modern mathematics. The Cartesian plane is composed of two perpendicular number lines that meet at the point of origin, which is 0, 0, and divided the plane into 4 regions called quadrants. It is composed of infinitely many points. Each point in the coordinate system is defined by an ordered pair of a form x, y, where x and y is an element of R. The first coordinate of a point is called the x coordinate or abscissa, and the second coordinate system is called the y coordinate or ordinate. We called x and y an ordered pair because it is different from y and x. The horizontal and vertical lines, typically called the x-axis and the y-axis, respectively, intersect at the point origin, whose coordinates are 0, 0. The signs of the first and second coordinates of a point vary in the 4 quadrants as indicated below. We have the first, the quadrant 1, the quadrant 2, the quadrant 3, and the quadrant 4. For the quadrant 1, x is greater than 0 or x is positive, and y is greater than 0 or y is positive. So the sign for the first quadrant, x and y are positive. For the second quadrant, x is less than 0 or x is negative, and y is greater than 0 or y is positive. Therefore, the sign in our second quadrant, the value of the x will be negative, and for our y is positive. For our quadrant 3, x is less than 0 or x is negative, and y is also less than 0 or y is negative. So therefore, the sign of our x and y value in the quadrant 3 is all negative. And for our last quadrant, which is the quadrant 4, x is greater than 0 or x is positive, and y is less than 0 or y is negative. The sign for our x axis in the quadrant 4 is positive, and for our y, it is negative. As we can see in our graph, we have y-axis for the vertical line, and our x-axis is the horizontal line. So our quadrant 1 will start in the right side, in the upper right side of the graph. Since we have 4 divided quadrants, so our first quadrant was here in the right side, upper right side. So the positive direction is upward and to the right. And then our second quadrant is upward left side. And then followed by our third quadrant is the uh, downward left side. And for our fourth quadrant is the downward right side. We have here our illustrative example. Suppose Mara and Clara belong to the class with the following seating arrangement. So we have row and column. So below is the teacher's table. So we have here following questions. First, using ordered pair, how do we describe Mara's seat? How about Clara's seat? And for the second, using ordered pairs, how do we locate the seat of any classmate of Mara and Clara? Can we make a set of ordered pairs? If yes, state so. For the first question, we are going to locate or to describe Mara and Clara's seat. So as you can see, Mara seat. Oh, so how can we find or how can we describe the seating arrangement of Mara? So from the row, it was in the line or in the row 3 and column 2. So Mara's seat is an intersection of column 2 and row 3. While Clara's seat is at the intersection of column 4 and row 2. In symbols, we can write uh, through ordered pairs 2 and 3 and 4 and 2 respectively. If we take the column as the x-axis and row as y-axis. For the second question, using ordered pairs, how do we locate the seat of any classmate of Mara and Clara? So we locate the seat of Mara and Clara's classmate by using column and row. We can use ordered pair, column and row to locate it. So since in our Cartesian plane, y-axis is the vertical line and the column is our x-axis rather is horizontal line. So therefore, we will going to follow that Cartesian plane or the ordered of the x and y. So therefore, our uh, x value will be column, and for our y-axis is the row. So for the answer on the question number 3, here is the set of ordered or the set of ordered pairs. So let's proceed to representation of a relation and functions. A relation is any set of ordered pairs. The set of all first coordinate is called the domain of the relation. The set of all second coordinates is called the range of the relation. Example: suppose you are working in a fast food company. You earn 40 pesos per hour. Your earnings are related to the number of hours of work. So here are the questions. How much will you earn if you work 4 hours a day? How about 5 hours, 6 hours, 7 hours, or 8 hours? So the answer for that question, so the earning depends on the number of work hours. An amount of 160 pesos is earned for working in 4 hours a day. So 200 for 5 hours, 240 for 6 hours, 280 for 7 hours, and 320 in 8 hours. So how does we find that answer? Simply by multiplying the amount or the earnings per hour times how many or the number of hours of work. Example, 40 per hour. So if multiply by 4 hours a day, so therefore 40 times 4, we can get 160. Question number 2. Express each in an ordered pair. So how do we express that in ordered pair? Simply 4 and 160, 5 and 200, 6 and 240, 7 and 280, and 8 and 320. So, last question. Based on your answer in item number 2, what is the domain and what is the range? So, the domain of the relation is 4, 5, 6, 7, and 8. The range of the relation is 160, 200, 240, 280, and 320. Why? How do we find the domain and the range of the relation? So, simply by identifying that all the first coordinate is the domain and all the second coordinate is called the range. So since our first coordinate is 4, 5, 6, 7, and 8, therefore that numbers will be our domain. And our second coordinates will be the range. At this time, we are going to proceed to the representation of relation. So aside from ordered pairs, a relation be represented in 4 ways. We have the table, mapping diagrams, graph, and rule. So let's discuss first about the table. So it describes clearly the behavior of the value of y as the value of x changes. Table can be generated based on the graph. Below is an example of a table of values represented horizontally. So we have x and y. For the value of x, we have -2, -1, 0, 1, and 2. And for our y value, we have -4, -2, 0, 2, and 4. Next is mapping diagram. Subsequently, a relation can be described by using a diagram as shown below. So we have x and y, same lang. Second, third is the graph. So below is also an example of a graphical representation of relation. It illustrates the relationship of the value of x and y. And for the last one, we have rule. Notice the table of value of y is twice the value of x. In other words, this can be described by the equation y is equal to 2x, where x is an integer from -2 to 2. So here is the domain and range. It is noted that the domain of a relation is the set of first coordinates, while the range is the set of second coordinate. So we have one-to-one correspondence, many to one, and one to many. Domain and range of a function. In the previous section, you have learned how the domain and the range of a relation are defined. The domain of the function is the set of all permissible values of x that give real values for y. Similarly, the range of the function is the set of permissible values for y, or f of x, that give the value of x real numbers. You have taken the domain and the range of the relation given in the table of values in the previous lesson, the set of ordered pairs, and the graph. Can you give the domain and the range if the graph of the function is known? So try this one. Try it in your own. Another example. Find the domain and range of each graph below. So how can we find the domain and range? By just simply looking at the graph. So in the first example, arrowheads indicate that the graph of the function extends in both directions. It extends to the left and right without bound. Thus, the domain D of the function is the set of real numbers. Similarly, it extends upward and downward without bound. Thus, the range of the function is the set of all real numbers. In symbol, D is equal to x absolute value of x, which is an element of R. Where in which R is equal to y absolute value of I, which is an element of R. So in example letter B, arrowheads indicate that the graph of the function is extended to the left and right without bound, and downward but not upward without bound. Thus, the domain of the function is the set of real numbers, while the range is any set or any real numbers less than or equal to 0. That is, D is equal to x absolute value of x, which is an element of R, and R is equal to y absolute value of y, in which is less than or not equal to 0. So for your activity and quiz, just visit https://gaitf.schools.sims/lcms. Thank you and God bless.